Continuity and differentiability. Exercise 5.4. Differentiate the following with respect to x. First question, e raised to x by sin x. So let us take y is equal to e raised to x by sin x. Now we will be differentiating each and every term with respect to x. Then we have dy by dx is equal to d by dx of e raised to x by sin x. Now it is of the form, that is d by dx of e raised to x by sin x is of the form d by dx of a by b, that is division rule. So we have d by dx of a by b, that is b into d by dx of a minus a into d by dx of b divided by b square. So substituting that here, we have dy by dx is equal to second function, that is sin x by d by dx of e raised to x minus e raised to x into d by dx of sin x whole divided by sin x whole square. So this can when we solve this, we have dy by dx is equal to sin x into d by dx of e raised to x, that is e raised to x itself. Therefore sin x into e raised to x minus e raised to x into d by dx of sin x, that is cos x, divided by sin x whole square, that is sin square x. So we have, that is dy by dx is equal to, we will be taking e raised to x from common from numerator. So we have e raised to x into sin x minus cos x divided by sin square x. So we have the condition for x, that is x should not be equal to n pi, where n belongs to n integer. Second question, e raised to sin inverse of x. So let us take y is equal to e raised to sin inverse of x. Now we will be differentiating each and every term with respect to x. So we have dy by dx is equal to d by dx of e raised to sin inverse of x. Now e raised to sin inverse of x. So we have dy by dx is equal to d by dx of e raised to sin inverse of x. This is of the form e raised to x, d by dx of e raised to x, that is e raised to x itself. So d by dx of e raised to sin inverse of x is equal to e raised to sin inverse of x into d by dx of sin inverse of x. Instead of x, we have sin inverse of x. So we have dy by dx is equal to e raised to sin inverse of x into d by dx of sin inverse of x, that is 1 by root 1 minus x square. Or we have dy by dx is equal to e raised to sin inverse of x divided by root 1 minus x square. And now here also we will be having the condition of x, that is x should be belong to the interval minus 1 to 1. Third question, e raised to x cube. Now we will be considering y is equal to e raised to x cube. Now differentiating both right side and left side with respect to x. So we have dy by dx is equal to d by dx of e raised to x cube. Now dy by dx is equal to e raised to x cube, that is, it is d by dx of e raised to x is e raised to x itself. Then instead of x, we have x cube here. So d by dx of x cube, that is 3x square. So we will be doing it separately, that is, first we will be having d by dx of e raised to x cube, that is e raised to x cube into d by dx of x cube, that is e raised to x cube into d by dx of x cube, that is 3x square. Therefore, we have dy by dx is equal to e raised to x cube into 3x square, that is 3x square e raised to x cube.